Okay. All right, hopefully people can still hear me on Zoom. For those who don't know me, my name is Michael Oberst. I'm an assistant professor in the Department of Computer Science, and we are getting a big notice that this is being recorded. Got it. I'm going to be giving maybe a slightly unusual talk today about real-world, in quotes, evaluation of machine learning and AI systems in healthcare, current state and open challenges. Let's see if my clicker will work. Oh, it does. It's just on a bit of a delay. Okay. So some goals and some context. So the idea to give this talk, I think originated the Malone Symposium for Engineering and Healthcare at our research symposium in December. We had a bunch of roundtables at that symposium on the evaluation, or we had roundtables on many topics. One of those topics was evaluation of ML and AI systems in healthcare. Liz was there, maybe some other folks were there as well. And then following that, Liz and I had a conversation about how it would be great to sort of build more connections across sort of computer science and other places at Hopkins that are thinking about AI, as well as folks in biostats. I think there's lots of valuable perspectives from biostats sort of as regards some of these problems. And so the goal of the talk today is not to present my own work. So I'm not going to be talking about papers I've written. I have previously given a talk in biostats sort of last fall on some things that are related to these topics, but I'm not going to be sort of highlighting work that I've done. What I'm trying to do here is to zoom out a bit and try and get people thinking, spark some discussion, maybe some interest in the area. I'm going to give some context for how machine learning and AI systems are evaluated sort of quote unquote in the wild in healthcare. I'm going to highlight some of the challenges involved in evaluating these systems. And my goal throughout is sort of ground in real world examples, as opposed to maybe grounding in particular sort of formalizations of the problem. There will be a causal graph at some point. The only purpose of introducing the causal graph will be to demonstrate that there are some things that the causal graph is probably missing. So I will talk a little bit about how people have thought about formalizing some of these problems. But I think the reality is that the practice of evaluating these systems sort of in practice has maybe gotten a bit ahead of people doing careful thinking around sort of how to set up the problem, how to think about some of the challenges that I'll discuss. So caveats, not a comprehensive view of all ML, AI, and healthcare. I'm not going to give sort of a full tutorial, nor am I necessarily the most qualified person to do so on regulatory regimes and how the FDA thinks about things, though we'll see a little bit of that. And some of this is my personal view, perspective, and synthesis. And of course, presenting more sort of messy conceptual problems rather than sort of nice, clean solutions and so on and so forth. So with that as a bunch of boilerplate out of the way, first, what do we mean by machine learning and AI in healthcare? I should also say, if people have comments, want to, part of the goal here is to spark discussion. So if people at any point want to jump in from my previous experiences here, I don't think that will be a problem. But figured I would have the invitation anyway. So what do we mean by ML, AI in healthcare? This is not going to be a comprehensive overview of all the ways people think about machine learning, AI, and health, but some motivating examples of things that are sort of actually used in the wild. One is early warning or alerting systems. Another is best practice alerts, image-based diagnostic aids. And more recently, there's been a big interest in generative AI and large language models for all sorts of tasks, and a very popular AI-powered documentation assistance. So one thing to note about all of these is that these are all sort of human-in-the-loop systems deployed in hospital settings that I'll be talking about today. Of course, there's lots of other applications people think about, but I'm not going to be talking about, for instance, AI chatbots to be your therapist, or systems that sort of consumers interact with, like ChatGPT Health, or things like that. This is going to be more focused on the healthcare domain. And so one example, just to run through those examples in a little bit more detail, One example of a type of system you can imagine here is early warning systems. So popular use case here is early detection of sepsis. So for those who don't know, sepsis is a sort of life-threatening condition that kills hundreds of thousands of people every year. So a big emphasis of the sort of machine learning for healthcare community, maybe for the past decade or more, has been developing predictive models to predict sepsis before it occurs, so that, ideally clinicians can intervene early and sort of avoid bad things from happening. And those are systems that have been deployed in one form or another in a lot of different health systems. So Duke, UCSD, Johns Hopkins at some point had a sort of deployment of this type of tool. Another sort of place in which machine learning can fit in, if the previous example was more raising alerts to clinicians to say, hey, look, you should pay attention to this patient, or raising alerts to other people, best practice alerts is sort of a term of art used to refer to these types of pop-ups, if you will, that occur in the medical record. So for instance, when you go to prescribe a medication, you may get a best practice alert that says either, hey, maybe you should think twice before prescribing this. Sometimes people develop these systems based on, in part, sort of machine learning tools, sort of informing the logic. So this is an example actually of a tool from a clinical trial. So this was something that was investigated, its utility was investigated as part of a randomized trial, where the user interface, it's very Windows 95 or something like that. Someone goes to prescribe an antibiotic and you get this alert, cefepime is not recommended for empiric therapy because we've judged the patient's risk of something is less than 10%. So instead we recommend ceftriaxone. You can cancel your order, override this alert, or sort of go along with it and click the replace to sort of swap out to the recommendation. This is not purely, all AI. A lot of this is structured logic that's informed by maybe some predictive models. More maybe modern feeling examples show up in the imaging space and in sort of the natural language space. This is an example, again, of a system for which randomized trial has been performed, which is a system to help folks when they're doing colonoscopies identify polyps that may be sort of precancerous adenomas. And I'm showing you a still image, but you could think of this as it's actually sort of done on a video. So as you're going through and you're doing your screening of the colon, your colonoscopy, it will do object detection to try and detect polyps for the clinician to potentially go in and remove. And another popular area, I couldn't get a good screenshot here because Epic is notoriously strict around putting screenshots of their technology on the internet. That's an aside. But Epic is the major medical record system that is used by vast majority of sort of large academic medical centers, including Hopkins. And Epic has been rolling out a lot of large language model powered tools, which they call AI for clinicians. And that's everything from AI scribes to help sort of document encounters. So you record your visit with a patient and then it drafts sort of a clinical note, to these sorts of applications, which I'll talk a bit more about towards the end, on sort of summarization. So doctors spend a lot of time reviewing notes to sort of understand the context of a patient. What Epic is sort of selling here is, hey, we could present a summary to you to save you time, sort of give you the key points, much like you might ask, say, ChatGPT to summarize a paper for you if you're into that sort of thing. I personally do not do as much of that, but this slide is just, hey, machine learning AI systems in healthcare are on the rise. This on the left is a sort of system I probably won't speak as much about, but Open Evidence is essentially ChatGPT for doctors, referencing medical literature and so on and so forth in order to answer sort of medical queries like what's the latest guideline around X, Y, and Z. It has seen dramatic uptake in the United States, at least according to the company, used by more than 40% of physicians in the United States. And anecdotally, having some physician friends, It is in fact a very popular tool. On the imaging side, which is more under sort of FDA purview, there's been, dramatic rise in approvals over the last 5-10 years. And so what I'll be talking about today, in the spirit of talking through some challenges, one is going to be the causal challenge, which is up top. And then the second one, which I also wanted to draw the attention of this audience to, is sort of remaining challenges even in just evaluating the systems themselves, especially when you get into some of these generative AI applications that involve large language models and so on and so forth. So the distinction here is whether we are evaluating the machine learning model by itself or the system by itself versus up here, what we often want to know at the end of the day is what's the effect of deploying this tool on outcomes that we care about. So whether that's patient outcomes, clinical decision-making, or something else, really the comparison we're trying to draw here is between humans alone, sort of standard of care, and human plus AI. And ask sort of, is it worth paying the cost? That could mean a lot of different things. It could be financial cost. It could be the technical sort of the cost of integrating something into workflows. It could be other sort of harder to quantify costs that you think about, like what if people become overly reliant on AI? There's some trade-off between risks and benefits of deploying AI. And so this is all about, can we quantify at least some of those and answer the question of sort of, is it worth deploying AI? And so for this, what I wanted to do is actually ground this in the context of randomized trials that have been done for AI systems. So I could talk about, causal inference and some of the ways in which this is a bit tricky to formalize exactly what we're trying to do, but I thought it would be more instructive and maybe open the aperture a bit for more sort of creative thinking among this community, just to ground in sort of actual trials. So for this first trial that I'll talk about, I'm going to give a little bit more of the clinical context. And I think it's an example that also illustrates a lot of sort of tangential points that I didn't sort of have time to get into the main talk. So context, what is a stress echo or a stress echocardiogram? It is where you do something like you run on a treadmill, that's the stress part, and then an echocardiogram is an ultrasound of the heart. So to try and diagnose issues related to the heart, so coronary disease. And the thing about the stress echo is that it is not necessarily a definitive diagnostic tool. So if you see problems on the stress echo, you think there might be a blockage in the heart, something that warrants more sort of interventional sort of cardiology. What you'll do is not sort of schedule someone for surgery. What you'll do is you'll do a follow-up test that is a bit more invasive. So an ultrasound, they just put something on the outside of your body. Coronary angiography is, in some sense a non-invasive procedure, but it's certainly more invasive than an ultrasound. You insert a catheter into a major vein or a major artery, rather. You sort of snake that around to the heart. You release some contrast agent, and then you take an X-ray, and that allows you to see in much more granular detail sort of blood flow and the like. So you don't want to do this on every person who comes routinely into the cardiology clinic, but maybe you want to do it on people where you think there's maybe a higher chance of there being something wrong. And so the idea here, where does sort of machine learning fit in, is can we take the echocardiogram and use that as input to a machine learning model to assist clinicians in sort of making informed decisions on whether or not to refer. And when I say we, I'm not really talking about myself. I'm talking about this sort of team. And I'm sort of going back to the original paper here, where they were sort of doing more development of this system, developing some sort of machine learning model. And the idea is they want to use AI to detect severe coronary artery disease. The details of the modeling are not super important. Lots of things get called AI, regardless of maybe how the underlying methods involved. But the methods here for the prediction are not sort of the main focus of this talk. What's interesting about this study is I think they actually had an earlier paper where they developed the tool and they evaluated on historical data. But in this study, they did what's called a reader study. So they actually make this claim, use of the AI classification tool increased inter-reader agreement and confidence, as well as sensitivity for detection of disease, and so on. So this is a type of already trying to evaluate the impact of this tool, evaluate sort of human plus AI versus human alone, where there's some sort of details. You know, the machine learning model produces some classification from the stress echo. Then they have clinicians, a small set of clinicians, 4 clinicians in somewhat of a laboratory setting, if you will, review each study with and without AI assistance. I believe the intent was we want everyone to see each study with and without. So there's some question of how do you do that without biasing them? So they sort of randomize the order and they add some washout period. And then the sort of claim that they make, you know, there's some further details here that are not super important, but it's just how do you construct a sort of curve like this? The main point they were sort of trying to get at here is, hey, look, the green curve is unassisted reads, and the red curve is these AI-assisted reads. So we're not evaluating the AI, we're evaluating AI plus human. And if you draw a vertical line at some specificity that you care about, you see that the sensitivity has gone up. And so that's that claim of, you know, this helps clinicians sort of come to better conclusions with higher sensitivity. And it was actually on the basis of this evidence that this gets FDA clearance. So this is, I'm not going to talk a lot about regulatory stuff, but this is an important note to know sort of in the how the FDA has approached some of these things in the past. So this is December 2020. That's going to be relevant for later when we talk about the trial. In the submission to the FDA to get clearance, this is what's called a 510K, they basically cited this reader study where they showed that, at least in this sort of laboratory setting, they saw improved sensitivity. And that was part of the basis for clearance by the FDA to do marketing. Now, notably, this falls into a category that lots of things get approved under, or really cleared under. There's a distinction between clearance and approval, where as long as there is some predicate device, so some other device that's on the market that does something similar, and that the FDA has previously cleared, the standard of evidence is essentially you're grandfathered in terms of like, as long as you can show that it's substantially equivalent to an existing device, you can get clearance to market. So for all intents and purposes, this is cleared to go in January of 21. First of its kind solution, presumably not first of its kind if there is a predicate device on the market, but that's maybe an aside. And then the trial actually starts after that point. So an interesting thing that may be unusual if you're used to thinking about pharma, for instance, is that trials are not necessarily a blocker for getting regulatory approval. Trials still play an important role, but you could think of that role as, depending on your sort of point of view, maybe cynically, it's a marketing sort of role. So you've got clearance to sell this product, but who's going to buy it? And which insurance companies are going to pay for it? And often they want to see some kind of evidence of clinical utility. Whether or not insurance companies actually want to see evidence of clinical utility or just want excuses not to pay for things is a whole separate conversation. But so this trial, the Proteus trial, begins in November of 21. The outcome measure that they're using is interesting, and this is something that I've sort of talked about with Liz, and this shows up in many of these types of trials, where the outcome is, they say AURC, they're really just looking at binary decisions, and they're trying to investigate if human plus AI leads to better decisions than human alone, and they're defining that as a basically appropriate referral to that follow-on test, where if someone gets referred to that follow-on test, they can sort of tell if that was a true positive or a false positive. You get referred, they do the test, they find nothing. Okay, that was sort of a false positive referral, if we think of that as a prediction. If they find something, it's a true positive. But if someone doesn't get referred, they have a hard time sort of knowing necessarily, was that a false negative or a true negative? So I don't refer you. So I don't do any follow-up testing. So it's quite possible I missed some coronary artery disease. But what I can look at is I can look if people die or have a sudden cardiac, a serious adverse cardiac event in the next 6 months after the trial. And sort of at least among some subset of people, I can tell that I probably missed something pretty important. And so this is the trial. Now we're 3 years after the trial started, 4 years after FDA clearance. This actually came out at a fortuitous time. I was teaching a class on machine learning in healthcare in fall of 2024, and this came out right before I had to teach the lecture on this stuff. So this is saying mostly stuff I've already said. It was a multi-center, so there's 20 centers across the United Kingdom over the course of roughly 2 years. The endpoint was the one I just described. And out of, it's a fairly sizable trial. Out of 2,000 plus participants, they had, 95% of them sort of complete 6 months of follow-up so they could check for those sorts of adverse outcomes. But then only 85 of the participants were actually referred for this follow-up screening procedure. Many of those did have significant disease. And of the patients not referred, 41 had sort of this adverse event that they could track. So then they compute their sort of metric of interest. They find that there's some slight improvement in this metric, 0.63 as opposed to 0.55. Neither of those, for those who know what AURC is a particularly high number. 0.5 is random guessing. So they saw some improvement, but it wasn't nearly sort of statistically significant. They weren't even going for superiority. They were going for non-inferiority, but they weren't able to sort of show that either. And so, of course, this prompts, when this came out, editorials like, we need more randomized clinical trials of AI because we need to know what works and what doesn't. But part of the reason that I highlight this example is because both of that kind of selective labels problem I just referred to, but also because it illustrates other kind of challenges that arise in this context. So one, if you were what's the word, optimistic person, or if you were a charitable person, and you sort of think it's reasonable, some of these sort of post hoc rationalizations for maybe why it wasn't significant, one potential reason is that the trial was actually too small. So they expected a higher kind of base rate of referral to this follow-on procedure, but at the same time the trial was going on, there was a trend towards referring fewer and fewer people to this kind of follow-on procedure in general, in part because people were less likely to recommend the follow-on sort of interventional treatments. And as an example of, the AI also has to work well. For a full quarter of participants that were put in the treatment group, they actually weren't able to get these AI assessments because of image quality issues. And that's something that you see in other sort of implementation pilot trials. There's some other examples I can point people to if folks are interested. You can think of this as, okay, I evaluated the AI system on a pretty clean set of data. Maybe I have some guardrail in place such that if it doesn't think it can give a good prediction because the image is not high quality, it sort of doesn't give a prediction at all. That, of course, can make it hard for recommendations to have an impact. So a theme in this area is there are lots of other trials, and I didn't want to talk about all of them due to time, that is of machine learning to assist with screening of some kind, with confirmation coming from a follow-up. Challenges, it's not always obvious when a model is a false negative if they don't receive a follow-up test. Another challenge is often in these settings, you are concerned about overutilization of follow-up tests. So you don't just want to say, in the treatment versus control group, did I diagnose more things? Because it's quite possible that even without AI, if you just put big alerts in front of doctors saying, hey, refer this person, refer this person, refer this person, they might refer more people and therefore find more things. They might find sort of incidental findings that aren't actually that serious. And so in general, there's this concern of overutilization of follow-up tests. So typically you include something about that. Many of these trials tend to be large. There's some that I'll talk about in a moment that are more on the scale of tens of thousands of patients. But even, of course, 1,000 to 2,000 patients is still quite large, from a sort of practical implementation perspective. One of the things I thought was interesting about this particular example is it's an example of healthcare moving quickly. There are other things that move quickly. You might think by the time you finish this trial, maybe you have a much better model, and now you can't say anything about that new model. But even in this case, part of the hypothesized reason, which you can sort of, some of the text is cut off, part of the hypothesized reason it failed was that this clinical practice changed. So another thing, I told you there'd be a causal graph at some point in here. Other challenges which relate as much to understanding like what we learn from trials as it is like answering this single question of like, does this particular AI system in this particular population lead to this particular outcome? A challenge in generalizing our findings or feeling like we've learned something sort of more broad is that the impact of ML and AI systems is mediated by human behavior. So for those who are looking for a nice kind of review paper on how people have thought about this, not necessarily in medicine, more in sort of social systems like criminal justice, I'll share the slides. This is a great review paper, Bridging Prediction and Intervention Problems in Social Systems by a whole slew of people. And at some point they draw this causal graph. I'm not claiming that this is their whole story. And they are aware as well in their settings of some of the issues I'll talk about. But even here, there's some complication. We have the covariates for maybe patients in our setting. We have this ADS, or automated decision-making system, or decision support system, which is producing these recommendations R. Then there are decisions D that are being made by some decision maker. And then we have some outcome Y. And we might be interested in lots of different questions. We might be interested in what's the effect of deploying the recommendation system at all on these outcomes. We may ask, what's the effect of these recommendations on human decision-making? We may ask, what's the effect just independently, like what sort of decisions by humans lead to good outcomes? That's a more typical causal inference policy learning question. But this itself is, to some extent, a kind of simplified model of the world. One reason is that human behavior can sort of change and adjust over time. And I didn't have time to sort of fit it in here, but there's a great observational sort of descriptive paper looking at sort of how clinicians interact with a particular system at sort of UChicago over the course of many years, where you see changes in sort of willingness to accept recommendations from the model. So you do a trial and you evaluate, okay, in the first 2 months of using the system, or 3 months or 1 year, like what's the effect? But there is certainly reason to believe that that effect may change over time as people become more acclimated to the system, either come to trust it more or sort of stop using it at all because they don't trust it, et cetera. So decisions may depend on previous interactions with the model, changes over time, sort of trust in the system in some way. And another complication is that in a lot of these settings, a machine learning or AI intervention is actually often a bundle of different things. So there are sort of per patient recommendations. There's also this idea, and it sort of relates to the first point, that there's potential for sort of spillover effects or interference. So if I'm a clinician using the system, each individual recommendation, I'm not processing it in isolation in an IID way. I may think back to all the false alarms I've gotten in the past and decide I don't trust them anymore. But in addition to that, the intervention itself is often more than just sort of a single model output. So an example of that, I'd pull another trial up, which is the INSPIRE trial. And this is around antibiotic stewardship. This is a pretty large trial, HCA, which is a large healthcare system, where they randomized 59 individual hospitals. This is a cluster randomized trial. People often do this type of thing because they sort of know that there are, well, in this case, there's actually more to the intervention than just the alerts, but in general, there's some sense of, okay, I don't want to randomize at the individual decision level. I want to randomize across individual users. They're either on the system or not. So in this case, it's hospitals randomized to the ML system or control, and they're comparing clinical outcomes, trying to assess the impact of deployment. Their goal is to reduce unnecessary use of broad spectrum antibiotics. The intervention is, I'll talk about it a little bit more, but I showed a screenshot before. It's not just these prompts that pop up that are powered by some risk prediction model. It's also a suite of like trainings and education, and basically all of, the phrase I want to use is whole of government effort, but it's not quite the same setting, to sort of improve antibiotic stewardship. Main outcome here is usage of broad spectrum antibiotics. Again, you have this tension where like, it's possible I could prevent people from using broad spectrum antibiotics by just telling them and hammering them over the head saying, please do not use these anymore. They are sometimes appropriate. And so they look at some secondary outcomes that are more around safety to see if there are sort of adverse consequences. And so this is the same screenshot I had before. Here, the intervention is Both the model, is a component of this. It helps determine when the alerts fire, but there's also this particular prompt and user workflow. You could imagine with a different user interface, maybe people's reactions to this or how it changes their behavior will differ, and also this additional sort of stewardship training. So I've had conversations with the folks who did this trial. So they have questions like we're actually not sure what parts of the intervention were the parts that mattered. If we had changed the threshold for the model, would that have made a difference? Or is this, mostly driven by other things, et cetera? And so here, the trial are positive, at least in terms of like people's used a lot less broad spectrum antibiotics, and they didn't see significant differences in these safety outcomes. And there's the reason I bring this back up, I'm not going to go through these in much detail, is just to say that even in these settings, there are differences in the implementation. So everyone's using some risk prediction model, but for instance, the Sepsis Watch implementation at Duke, and I can link people to like lots of great papers on going through all the details, involved, for instance, a separate team of nurses whose job was to like review alerts in kind of a command center and then like take action in response to alerts. Whereas the system at Hopkins, for instance, was more, putting something in the EHR as a like less obtrusive sort of alert. So it's not just blaring at people all the time, but is something that is more to be used by sort of rounding nurses in addition to sort of their everyday job. Also differences in models and sort of performance of those models, all kinds of differences that maybe all contribute to different effects. So summarizing this part, and then I want to spend a little bit of time on generative stuff. Even for predictive models, even when we have randomized trials, there are challenges in understanding causal impact. Are we measuring the effect on the outcome of interest? Maybe we care in the case of the heart sort of example, the cardiac example, we care about long-term outcomes for people, like their heart health if they have a heart attack. But it is hard to set up a trial for that, both because effects may be marginal, on that sort of full primary outcome, but also because it takes a long time to run those trials if you have to wait to sort of see those long-term events. So we use some proxy like short-term decision-making. We don't always observe things. And the second point is in normal randomized trials, we already have, a lot of interesting thinking and, maybe challenges around generalization. Like we've done this trial in this population, but does it generalize to other populations? Here we also have questions of not just the patient population, but the user population. There's concerns with trials that like, are the doctors who volunteered for the trial all techie early adopters and their reactions are not going to look the same as if you deployed it in practice with lots of people? We're using a specific version of a model, and often in machine learning, we want to update our models over time. So what can we say about other models? And, all these other decisions that go into actually like, how does this get implemented in clinical workflows? Then I want to say a little bit about this second part. It'll be a bit shorter than my first part. But this is, even this part, how to evaluate the AI system by itself, is a bit tricky, particularly for what I call generative AI systems. So for some context here, I'm going to maybe not spend too much time on these slides, other than to say doctors spend a lot of time in the electronic health record. This is, the curse of the electronic health record. Nowadays, you may have been at talks where people are like, look, over time, so many more things are now in the electronic health record, and this is wonderful. Hospitals are finally not using fax machines as much anymore. The downside is doctors spend a ton of time on documentation. So this is a study based on data from Epic, where this is all normalized to 8 hours of scheduled patient care. And for each 8 hours of scheduled patient care, doctors are spending, an additional 6 hours, or maybe, 6 hours in general in the EHR. So that's not all outside of those patient care hours. But about 50% of that time is spent outside of scheduled clinic hours. So this is, you're catching up on your notes on the weekend, you're preparing for your patients the next day after dinner. There's a lot of burnout and concern around clinician well-being in the healthcare system for good reason. And so when Epic, and other providers sort of come and say, hey, we have tools that can help you with your documentation, help speed things up, maybe that's a potential solution. and so on. Full disclosure, okay, so one area here is what's called AI scribing, which I'm not going to talk about as much. I'll talk more about the summarization piece. On the AI scribing side, so these are tools where you record your patient visit with a doctor and then it drafts some clinical documentation for you. There are also randomized trials. A lot of them are very recent randomized trials because this is a technology that has been rolled out very rapidly, and the trials, and very recently. So these are from late last year, so 2025. There are more recent trials that have also come out which tell broadly the same story. But an interesting thing you'll note if you look at these trials, or if you hadn't seen this slide and then you sort of thought to yourself, what do I think they will report in the trial? You may be surprised when you go to the trial and the outcomes they're looking at are not, what's the impact on patients or what's the impact on clinical care or things like that, which I think there's reasons around it's sort of tricky to measure some of those things. But instead, the primary focus is on impact on clinicians, things that are a bit easier to measure. So survey-based measures of professional fulfillment and burnout, secondary measures, or in some case, the primary measure is also time spent on notes, so time spent doing documentation. Generally, people find that there's some, as you might expect, reduction in the time spent doing documentation, very large reductions in sort of feelings of burnout, and so on. My sort of full disclosure here is I spend some time sort of consulting with and collaborating with an AI scribe company. So take all of my opinions on AI scribes with a grain of salt. So instead of talking about scribes, I'll talk about something a bit different, which is summarization. So I talked about that before. Epic sort of selling tools around, hey, before you go see your patient, maybe we can summarize all of the previous notes for that patient and present you a nice, easy to digest summary. You could imagine running some trial on that and asking, does that save doctors time? Maybe it does, maybe it doesn't, depending on how much doctors trust it. But certainly something you'd be interested in is actually evaluating the quality of the output. So are these good summaries? Do they capture all the right information? Are the LLMs hallucinating content that does not actually exist in previous notes, for instance? And so there are metrics and tools that people use in this context, or really that predate this context. So people have come up with documentation quality instruments, which is just sort of a Likert scale scores in a couple of different categories for people to review clinical notes and basically ask, is this a good clinical note? And it contains, admittedly not very descriptive categories. Like this is the entirety of your guidance on how to rate something for accuracy. Accuracy refers to the note is true, it is free of incorrect information. Please rate from 1 to 5. What does a 4 mean? What does a 3 mean? Not necessarily entirely clear. And so for a lot of these types of measures, you get sort of fairly poor inter-annotator agreement. This is something that also comes up in sort of the sort of CS, ML, natural language processing side. People in machine learning love to have competitions and benchmarks. And so one such competition was in 2024, the shared task on clinical text generation at a biomedical language processing workshop, where one of their challenges was, hey, take all these notes and write a discharge summary. And then for like the people who perform best on our automated measures, we'll have humans review them, we'll have humans score the outputs, and we'll get some sort of ground truth on sort of who did the best job. And so they asked 6 doctors to review the generated sections for completeness, correctness, and readability, as well as some sort of holistic comparison against a reference discharge summary. And they did this sort of Likert scale feedback. And one of their takeaways was there was rather poor agreement between most clinicians, perhaps because one person's 3 is another person's 1, and sort of vice versa. So there are sort of challenges here getting to sort of maybe construct validity in terms of some of the instruments that people use, even when you are having humans sort of do this expert review of notes. So there are examples of folks more on the sort of informatics side, trying to push this forward and make things a bit more structured and clear. So this is a paper from folks at University of Wisconsin-Madison, where they, identified some domains that, so far it looks pretty similar. I have some broad buckets like accuracy is the same as the one I showed you before. They have some additional domains here that are slightly different from sort of historical instruments. They're still using Likert scale feedback, but what they're also doing is providing more of an annotation guide around, okay, what counts as a 4, what counts as a 5, what counts as a 3. So there's some push to like make the rubric a little bit less ambiguous, and they see sort of higher, still not perfect, but higher sort of inner rater reliability, where the whole purpose of this study is not even to evaluate an ML system, it's to take outputs from some off-the-shelf LLMs, some systems, and just have people grade them and hope that they see sort of high agreement between raters to try to validate this instrument as sort of giving you reasonably repeatable results. There are still questions there. The examples you look at matters a lot there. If all of the things you look at are all perfect, then maybe your annotators all agree they're all perfect, but you're not exposing disagreements they would have in sort of imperfect cases. Of course, some of these domains are maybe a bit more important than others from a risk and safety perspective. How organized or comprehensible a summary is nice as a user, but maybe if I'm a healthcare system thinking about governance, I care about, are they thorough, are they accurate, and so on. And there are, this is actually from a clinical collaborator. He had sort of come up with some examples here of like, even for numerical measures, if I mess up the respiratory rate and I say it's 23 instead of 24, that's not as much of an issue as if I say the creatinine is 3.3 as opposed to 2.3. Like that's a huge difference, and it makes a big difference in terms of how you treat the patient. Similarly, if you think about what gets omitted from a summary, which is a major concern, in some sense it's easy, not easy, but at least like feasible to think about checking everything. You can imagine telling users like cross-check everything in the summary and make sure that it's right. Harder to say, hey, make sure there's nothing missing from the summary without having them go back and read all the notes themselves. So omissions is a big concern for folks in this area. And like history of hernia repair 5 years ago is maybe not relevant for a lot of things, but knowing that someone had a renal transplant 5 years ago matters a lot in terms of sort of thinking about future treatment. Collaborator is an infectious disease doctor, so I think he's approaching it from that lens, thinking about immune system stuff. There are other more granular types of annotations of things you could do, like looking at individual sentences, trying to flag things by their severity, not just whether or not it's an error or not. But the sort of point that I wanted to get to is another challenge here is that even if you get the perfect rubric and you get your annotators to agree on it, and you conclude like, if I'm getting pretty consistent results and I think I have good like construct validity, I think this is measuring what I think it should measure, then you run into the problem of like, okay, so now what am I going to do? Am I going to have clinicians review, so many hundred examples every month to make sure the system is still performing as intended? If I do this validation in one system, does it apply in another system? Well, you'd probably say, hey, maybe you should do some local validation in your system that it works. All of this requires a lot of human effort. And so one approach that people are excited about, I have the obligatory turtles all the way down figure here on the right for its LLMs all the way down. When you think about automated evaluation in this space, is to what extent can we automate some of these evaluations using other sort of capable large language models? And this is what people refer to as sort of LLM as judge setups. And so actually that same group from University of Wisconsin-Madison who developed this rubric also did some sort of LLM as judge evaluation to try and convince themselves and the reader that if you give all this content to a large language model, so you give it the raw historical notes, you give it the generated summary, you give it the evaluation criteria, you give it some instructions on how to apply the evaluation criteria, you get some scores out of the LLM, and then you can ask, how well does this align with sort of the scores of human experts that you have annotate along all these domains? And you can look at things like the average bias sort of within each domain. You can look at other metrics of sort of inter-annotator agreement where one annotator is the LLM and so on. But I think one interesting challenge here is the challenge of when are your LLM judges good enough? So certainly I've seen this in the clinical domain. People are very wedded to the idea of we have validated something and now it is validated. And so now it's a validated thing and we can use it. So like that's how a lot of these instruments are framed. Like, why are you using this particular rubric? Well, it's a validated rubric. Someone wrote a paper showing that it is high fidelity, it's highly correlated with what humans would say, and we never need to revisit the question. Similarly, there's a temptation to say, we validated this LLM judge. It has high concordance with humans, and so now it's sort of a binary, it's been validated or not. I bring up, this is MedHelm, it's a benchmark, really it's a collection of different tasks sort of aggregated into one big sort of framework by folks at Stanford, biomedical data science. And in this, their goal is, they want to make these leaderboards. Sorry, I'm going back to the previous slide. These leaderboards, like how good is GPT-5? How good is GPT-5 Mini at medical stuff? Where they've come up with a bunch of different tasks, different evaluations, benchmarks, et cetera, to come up with some kind of leaderboard. Some of these tasks are closed-ended tasks, like it's multiple choice questions. Some of them are open-ended tasks, like there's this it has a lot of limitations, but ACI Bench is an example of a data set that people use for sort of this summarizing of a patient-doctor encounter, and so on and so forth. So these are open-ended tasks. They have an LLM jury, which is lots of LLM judges, each arguing with each other to come to some conclusion. And they show it has, an interclass correlation coefficient of 0.47 in terms of sort of comparing to agreement with clinicians. And their basic takeaway is the LLM does not consistently agree with clinicians, but clinicians don't consistently agree with each other either. So this is probably good enough. Establishing its validity as a stand-in for clinician raters. Maybe I shouldn't harp too much on overly incautious language, but there are, I think, legitimate questions that people have around, when can I take something that I validated in one place, even like on the LLM judge side, and apply it in another place? Certainly, at least the standards when it comes to these benchmarking tasks is not necessarily super high. But there are lots of sort of challenges here from the rubric design itself. So do the rubrics have construct validity? Do they measure what we think they're measuring? Maybe doctors all agree on the ratings, but when you then ask doctors, okay, but like, would you trust this note? They're like, oh, of course not. Like, based on your rating, I would have given it the ratings according to the guide you gave me, but maybe it doesn't sort of measure what we think it's measuring. How do we think about variation, expert evaluation? How much of that is expected due to inevitable ambiguities in our rubric? And there's some interesting work around, what can go wrong if actually your rubrics have multiple right answers and you're forcing people to choose one of the answers from a sort of robustness perspective. How much is this caused by natural human variation and sort of preferences, like variation we'd expect to see that maybe has some signal, or maybe some annotators are just not paying as much attention to the task, or have lack of expertise. How do we know if our conclusions about annotator agreement generalize? When can we rely instead on sort of natural feedback? So user submitted feedback as a source of ground truth. And that starts to get into questions of automation bias. And this also comes up, by the way, in the radiology examples. You have people using radiology tools for assistance and diagnosis. And then if you take as the ground truth, what was the right diagnosis, the decision that the doctor came to and put down in the note, you start to have questions of like, well, now the doctor is using the system and maybe the doctor is wrong and they've been misled by the system. So instead of just looking at sort of the user's output, maybe we need these sorts of retrospective reviews. And then, obviously challenges with this or conceptual questions to ask around sort of reliability and robustness of these types of LLM judge systems. Suppose we validate one, sort of quote unquote, when can we rely on it to evaluate new models, new outputs, lots of questions of sort of generalization, how to formalize, or I think even sort of incorporate ideas around sensitivity analysis here, for instance, having more robust evaluations. And that is going to be, I'm going to sort of try and wrap up here. Summarizing generative AI, from a causal perspective, we have all the same questions. Long-term effects, long-term outcomes we care about, proxies for quality we rely upon, et cetera. But there are further questions with evaluating generative AI systems, even just the system itself, around the rubric, automated evals, user feedback, et cetera. And I will sort of leave it there. We still have some time for questions and discussion. and I will end abruptly on this. I don't know if I can see the Zoom chat. Can you see the chat? Are there questions in chat? Okay, see right now. Appreciate it. It's maybe just, sparking some thoughts. I'm going to share the slides. There are some things that I alluded to that I didn't put references in the slides, but I'll also include those when I share the slides. Sorry, question?
Oh, I just wanted to thank you for the outstanding talk. It was really fantastic. This is Michael Rosenblum from Zoom. Um, yeah, I didn't have a question, but I will come up with one in the next few minutes. But this is I just wanted to say how this is a excellent talk, super important research.
Awesome, thank you.
I agree. This was really thought-provoking. Thank you, Michael. I have a question about like externalities. Like if we, on the one hand, I was thinking doctors being less burnt out and being able to spend more time with patients is probably an externality that's good for patients' health. And then I'm also thinking like relying on these AI systems will just reinforce reliance on them in other ways and, like accelerate a process of bringing the human out of the loop maybe before the systems are ready. And I'm just wondering if you think about those, I know there's no answer, but do you think about that? Is that something that's being thought about in these studies and in this context?
I think there are it's a thing people think about. I could, rattle off some other things people worry about. I mean, one concern you might have is like, okay, maybe it saves time now, but then if like that value is captured by the health system, having people see more patients, maybe we've put ourselves in a bad situation. So more policy level, almost society level questions. There are worries around training, and both like people see potential in some of these tools for training. Like if you can, if you're recording, patient-doctor conversations where a resident is doing the visit, and you have their note, and you also have the transcript and the recording, you can sort of give feedback and that sort of thing. I know some people are looking into sort of aspects of this for training, but there is a worry around, to what extent do people worry about, well, writing is kind of, on the one hand, there are a lot of people who really like this stuff. I mean, I shouldn't understate like the reason that a lot of these tools have been rolled out is because doctors really like them in the large. But there are concerns, with either like de-skilling or negative externalities of, if the resident never learns to write a good note, are they really doing the thinking they need to do to sort of process what they learned in the encounter and so on and so forth? And where does some of this stuff cross from decision support crossover from documentation assistance to decision support? So anyway, it's things people talk about and think about. I think from a studying it perspective, there are studies, and I think this is the sort of types of studies that we need in this space of not so much on the generative AI side of things, but on the I think we need it there too, but the studies I'm familiar with are more in the like radiology case. So there are studies on like automation bias. And like if you give people a system that gets answers wrong and it's, do they start to make errors they wouldn't have otherwise made? And there's studies on this actually going all the way back to the like early 2000s with like not so like simple sort of automated systems for diagnostic assistance. And then people more in like the human computer interaction space, and there's some folks like this at Hopkins who think about these problems in computer science and I'm sure elsewhere, think about like what's the value of explanations? Like if I give doctors explanations alongside a prediction, does that actually enable them to detect when the predictions are wrong? And sort of doing more laboratory studies where you say like, okay, I've deliberately made some of the predictions wrong and the explanation kind of nonsensical. Do the doctors catch it? And that sort of thing. But I think it's it's challenging. And one of the challenges that I've heard from colleagues who work on this sort of human-computer interaction side is how a clinician behaves in a user study might be quite different from how they behave in practice with a real patient. So you get some volunteers, some collaborators to like click through some things and say, oh yeah, I call it this, I call it that. But actually behave quite differently when they are like actually interacting with this tool in real life, or maybe there's an extra level of sort of scrutiny that's applied. So lots to think about. I think a lot of this stuff, it's challenging to disentangle lots of things you might worry about, both short-term, long-term. I see Michael has a question.
Yes, I wanted to ask about validation standards and guidelines for validation of AI-based tools. Do you? It's an area I'm very interested in learning more about. I was curious if that comes up at all, or if you have
Yeah,
any
so
thoughts on that.
it's much more mature in the predictive models space.
Mhm.
So there is this concept of what's called a model card. So there are organizations like CHAI is an organization, Coalition for Health AI. There are a couple of other sort of nonprofit-esque sort of bodies that sort of try and really help health systems think through, like, how do I validate some AI system that I may be bringing into my hospital? A lot of that is, I think we're just getting to the point where that's a little bit more mature on the predictive model side of things and less about interactions with users and just like, hey, it's sort of like checklists for observational studies by analogy, like,
Mhm.
what's the cohort you validated it in? What were the precision and recall number, the sensitivity specificity numbers? Like, how did you account for missing data? Like, basically a structured sort of thing really aimed at giving hospital systems the tools to go to vendors and say, like, we need you to fill out this model card and give us these details, as opposed to just coming and saying, like, hey, we have a whiz-bang tool, you should turn it on. A particular, I don't want to say offender here, but like a particular a thing that happens is Epic itself is both the medical record system, but also has a bunch of these add-ons. And so we'll go to health systems and be like, hey, why don't you switch on the Epic predictive model for X? It will just put it as part of your subscription. You turn on all of these additional AI-powered alerting features. And so I think there's more consensus on validation for those sorts of systems. I think there is a lot less in terms of, from a like implementation perspective, like it's still a very, very much an evolving space on standards for like generative AI systems, like summarization, or nobody knows, maybe how we should be evaluating open evidence. Is it giving us good answers? Open evidence, actually, interestingly, I've talked to a colleague who's thought about this, actually not at Hopkins, and they told me open evidence has a term in their terms of use, which basically says you are not allowed to evaluate the outputs. Like, if you're a researcher, it's the terms of use to ask a bunch of questions and then like do some, review and publish a paper.
Wow.
They've also been told that probably wouldn't hold up in court if they really wanted to push on it. But there's, anyway, that's a whole other aside.
Interesting. Thank you. Yeah, that's a great
Question.
answer. Thanks.
Yes.
Yeah, for the human mediation component, have you thought about how like the context of like how negative decisions will be treated? Like, will the blame be different than if it was just a human decision versus AI mediated? Say the AI gives.
That's a great question. And I think fits into Betsy's question about negative externalities as well. Or like, concerns that people raise. I don't know to what extent one needs to, there's some complexities there. A lot of people think about malpractice, and they think about like, if an AI system predicted this and I overrode the alert, but then you had it, will that look bad? I think the way that you'd generally expect that to be handled is sort of like, there's a notion in malpractice of standard of care, but also like the care that another reasonable person would provide in the same setting. And so it's not, but it's the thing people worry about is like, if there is like doctors worry about, part of the reason doctors don't necessarily like a lot of sort of alerting systems and the like, is, feeling like I have to chase down all of the alerts that it raises, because if I don't, and one of them is real, I would look bad. So certainly something that people worry about. A quick aside is that most people, when they come to machine learning for healthcare, from first principles, they think, well, surely the thing you care about is catching the stuff. That's the real problem, is you don't want to miss anything. So I'd much rather have a bunch of false positives than like false negatives. And actually, for a lot of these alerting systems, it's sort of the opposite. Like, doctors will not use a system that is constantly flagging false positives. And there's like a lot of alert fatigue and stuff like that that sort of comes up anyway, especially in this sort of sepsis case. Yeah, Helen?
Yeah, so you had this slide that talked about how people kind of look at binary outcomes using an AUROC curve. And I'm wondering, like, generalizing that, have people looked at it from like a more complicated perspective instead of like true false or yes no answers? And what does that look like? Like, where are we in that?
I don't know that I've seen one thing actually, I'm glad you brought it up, because one thing that stands out to me from that trial is you could actually imagine there are sort of different types of false negatives. Like it's very different. Like there's a false negative, like a doctor would have been able to confirm some disease, but like the person would have lived for another 5 years, versus a false negative, like they died in the next 3 months from a heart attack. So there's some like severity of error that doesn't sort of get captured there. I'm not familiar with people like thinking more deeply than I've just described about it. I think it might be an interesting, maybe it's worth talking about sort of offline afterwards. Certainly in the sort of like generative AI area, people are like still trying to wrap their heads around, like there are different types of severity of errors. So it's not just like binary, like this note was, had some mistake in it or this note didn't. Like there's a big difference between like, I messed up one little sort of thing about your social history, like your wife was also in the, visit and said something and I attributed it to you, but it's like about your dog, like there are little errors you can see in like automated documentation that like really don't have much of an impact. And then of course there are potential errors that are much more serious.
Thank you.
Yeah. Any other questions, comments, concerns, compliments? I already got a compliment, so I won't ask for any more of those. How much are the barriers to evaluation inherent and don't reduce with improvements in generative AI models? I just saw that first snippet of the question.
The model quality versus things that will change substantially with model in the next few years.
Yeah, so I think the one thing that I think you've seen in some of these spaces, or at least that I've seen, and partially this is like collaborations with folks who work on some of these systems on the industry side, is like as models improve on the generative AI side of things, like there are still problems and things that are not the ideal output, but it's no longer like really obvious stuff. Like you don't generally have the like, wow, the AI just completely made something up type of problem. You have like errors that can be sort of very subtle errors that are like, maybe, I mean, some of them are not mistakes that humans would make, but it's sort of like you get into these errors that are like, I can see how you got there, even though that is not sort of the right thing to maybe put in a summary or put in something else. So I think it's, that's one thing that changes. I don't think it certainly does not by any means remove the problems. Like my sort of impression of the space is like, as capabilities improve, what you do is you push into areas. It's sort of like, you get promoted into the job you're not ready for. So you're always not always super good at the job. Like until AI is running all of healthcare, there will be this, progression of like, for instance, people are doing pilots of like AI for doing clinical decision-making around like refills of prescriptions in Utah. Like what ends up happening is people like, even if capabilities improve and now in one domain, you're like, oh, that's fine. It was just solved by the generative AI models got much better. Now you have all these other domains where you're like, okay, now we're pushing on stuff where maybe it's not quite ready. So I don't think it's a story of like, well, all these problems will be solved by scaling, which is sometimes something people talk about on more the ML side of things. One nice thing about it is it does give you, like, I think a lot of these LLM as judge frameworks, like a lot of the problems that show up become more, how do you define what you're looking for? And a little bit less like, can the model follow instructions to pull out the things that I'm looking for? So, you know, insofar as like, it also leads to improvements in our ability to trust automated evaluations. That's a good thing, but I think it'll be a messy space for time to come, even when, you know, GPT-7 comes out or whatever. Any other questions? If not, thank you all for coming, and thank you folks for joining on Zoom. It was wonderful to bring all this stuff to this audience. And I would love to have follow-up conversations with, you know, anyone and everyone who wants to talk more about this stuff. I will send a sign around slides and papers and that sort of thing. And yeah, thank you all so much for coming.